Hi, Marie Curie. This is Ms. Cooper. Just going over the lesson a little bit in shorthand. I know how much you guys like when I cover stuff like really quick and like less time. So here, this is to understand conservation of charge, mass, and energy. Remember, it's nuclear waste, nuclear energy, nuclear chemistry. You have to know that it's hard to get rid of because it hangs around. And that means that mass and that charge and that energy hangs around for a long time, right? Not only does it hang around for a long time, it's difficult to get rid of. So if we go over to this board, we're using table N. Don't forget your success criteria, 4 out of 5, meaning that you must have 4 out of 5 answered on each sheet, worksheet, homework, and have explanations. Worksheets and homework and must have explanations. So we go over here, this is the mini notes. We had this particular equation, I'm going to go slow from left to right. This is question number 24 on the worksheet. Here goes your mass, 235. All right, this is 142, 91, and 3x. These are all examples of the mass, right? And we're saying our reactants equals the products. When we talk about conservation, the conservation of my masses will equal the mass of my product. So when we look at these equations, that's what we're going to do. I know a lot of you have problems transcribing, so what we did is the 235 plus 1 is 142 plus 91 plus 3x. And it has some energy. If I go down here, I just take the mass out of that equation above, which was the 235 plus 1 is 142 plus 91 plus 3x. So this is just the masses. Here I'm showing you when we add them up, it's 236 equals 142 plus 91, which is 233 plus 3x. When we go down here, what we'll just get like terms together, so that's why we take the minus 233 and minus 233. This becomes a 3. 236 minus 233 is 3. And then this equals what? This becomes 0, and then this was 3x. We've put it down here. So the 3 is 3x. This little line that I'm putting here is to mean to divide by, so it's 3 divided by 3, and we take that. So 3 over 3 is 1. 3 over 3 here is 1. Anything over itself is always 1. Don't forget 404, 505, 606, 707 is always going to be 1. So x is 1. So x on this side of the equation equals the atomic mass. So whatever my answer is here, x is going to be the atomic mass. So what I did is I put a 1 in part of my answer for x. Now, I like using the variable x, so I stuck with that. So now you're going to look here. Atomic numbers are all in red on the bottom. See them there? See them? So cool, so cool. So I have 92 plus 0 is 56 plus 36 plus 3x. I take these down here. What we could have done here, let me just come to the board here for a second, because some people were confused about this. So one of the things I could have done is done this. I could have just wrote a little 3x here. And I could have kept that up here too as a 3x. That might have worked also, so that you guys wouldn't have got confused. Because I just had 3x there. Because I just assumed that everybody knew I was doing the 3x, right? So you got to remember, you don't understand, raise that hand, especially when you're doing checking for understanding. So let's do that. Let me move back out of the frame. Here we go. 92 plus 0 is 56 plus 36 plus 3x. I write it here. 92 plus 0. 92 plus 0. 92 plus 0 is 56 plus 36 plus 3x. I wrote it here. 56 plus 36 plus 3x. See it? And then I took it down here. 92 plus 0 is 92. 56 plus 36 is 92 plus 3x. Put it here. We wrote it just to make it neater so you can follow. 92 is 92 plus 3x. Get like terms together. This minus that is 0, right? 92 minus 92 is 0, but here what's left over is 3x. 0 equals 3x. Now I get x by itself. I divide by both sides by the same thing, 3 and 3. Then I get 0 equals x. All I got to do now is put this 0, this x value over here. This becomes x with this atomic number 0 and atomic mass. And if I look in table N, I'll see that this is the particle. It's a neutron. So if I want to rewrite this equation, instead of having this 3x here, let me erase that 3x. What do you think I'm going to put there? You're absolutely right. We're going to put, sorry guys, I got to go in and out. it's going to be 3 in, and I have what value here? I have a 1 and I have a not, right? So that's what we're going to have, 3 neutrons here. I got bombardment going on the left, bombardment on the left, and then I get a product. Do you see that product? I am so proud of you. Okay, so why do I box my answer? Yes, you're absolutely right. So that you can find it. Right. So if I had to do this on the exam, this number I finally got down here, like you did on your worksheets, you have to plug it back in the equation. So anytime you find the particle that's emitted, you have to do that. Now, if you're new to this, you want to use table N. The room is kind of messy. So I'm going to have the recording just go to the floor, pan to the floor a little bit. You see all this beautiful work on the side of the room, forgive me, but the room is messy. So I go down here, and I know you saw some of my mess, but that's okay. This is table what? Table N. N tells me the type of mode, the decay mode, and it tells me the years. Do I need table N? No, but I need table O. Here goes table O. Table O will tell me what my particle is. Do you see it there? And that tells me that it's a neutron, clearly. And I can write it if I forget. There goes my symbol. I can use either one of these symbols in my work. Okay, guys, I know you saw the tape on my hand, but that's okay. First video, first take. I think I'm going to leave it like this because I want to go home. So once again, we're going to use table O and table N. And this spells on or no. So get on the no-no. Go ahead, Marie Curie.